Okay, we are back once again. It is day 91, I believe. The setup is a little funky today. It is what it is. But we're back once again. We were working on some problems yesterday. I was reading a lot about I'm reading a lot about CAP theorem, which is a relationship between consistency, availability, and partition tolerance. But I'm going to be honest, it's not making a ton of sense, so we're going to keep reading about it, see if it continues to make sense. But system design is pretty interesting, man. I feel like even some of the things I'm learning are making me like portabilize the ideas and bring it to code, but we shall see. And I hope we keep getting better. I had some good encouragement from the gang, Thomas, yesterday. We were able to figure out the problem with our binary tree post order traversal. So today I'm hoping that we're working on isomorphic string. So I'm basically hoping that we can get this problem over with. We already did it, and I don't know if there's any worth to figuring out how to do it in linear time, but I think we might spend today trying to do it in linear time, and then we'll see how that goes. So I think we're just going to jump into it. So let's do it. So yeah, also no timer yet. We'll get this figured out, but I can see the timer on my end. But yeah, so given two strings. So yeah, we were working on this yesterday. We got it to, I think the runtime was very, very, very bad. And actually I have to make my camera smaller. I think the runtime was very, very, very bad. And it is 490 milliseconds. I think there's a part basically where we're basically continuing to append strings to these hash values, and then we check for the values of the hashes themselves, and this ends up being a problem. Maybe we could simplify it. First, I think we need to get a handle on what exactly is happening. What if we put s sub hash, and we'll do, actually no. After this whole thing, we're just gonna put s sub hash and then put t sub hash. And then we'll see exactly what we're doing. This looks fine here, but for a string that can go up to 10 to the 4 5 times 10 to the 4 characters, this gets pretty crazy. Especially since we're comparing. And we always do this does not equal portion, which I think Reed has us doing a lot of work over and over again. I think it might be, well, basically I think we're doing n squared time right now. I want to get this down to linear time. And I think this is because we're always adding another index, right? So we have the character, right, which we get, since both strings are the same length, we take the individual indices, we get them into characters s and t. From here we have s hash sub s sub car, because we're mapping a letter to the indices, right? So it might be good to say that. Mapping letter to duplicate indices, right? As a string, this gets pretty long. This gets pretty long. So I think it's really just this comparison part that's taking the longest. I really feel like. So what if we I guess my plan would be maybe we could move this comparison block outside of this and then into just a check we do at the end. And then I'm thinking that might reduce how much time. Well, this one's, yeah, how much time this is taking. S sub hash, S sub car, T sub hash, T sub car. We do this over and over and over again, even though we're adding to the characters. So my worry is if we get to the second G, right, and the second D, we do 1, 2, right? Now let's just say this string is 99,000 G's, right, and 99,000 D's. We end up redoing this character by character comparison for the strings, which is why we're ending up with n squared time, I think. I think we could simplify this. I think if we skip the comparison here and then just compared the hashes, right now the hashes have different keys, so I think we could fix this if instead of using the character as the hash, we just used the index itself. And we should get a failure, but I just want to see if it maps. So we're still I think this is the problem. E would map to 0 and G would map to 1, 2, and A would map to 0 and D would map to 1, 2. Isomorphism. Definitely is a linear time solution here. Maybe there's not a lot of value in trying to get this to linear time, I think. Where we can come up with a whole suite of different solutions sometimes. No two characters should map to the same character. I still don't understand what this means. Placing each character in string S with the character it is mapped to results in string T. Matching the order will be easy since we iterate over the two strings and we do some sort of comparison from left to right. Task of ensuring that the character order is the same both strings will take care of itself. this point, we don't have any mapping between the two characters, so we add the corresponding mapping to the dictionary. P maps to T. Need to decide on one thing and be consistent. So when a mapping already exists for one of the characters, but it doesn't map to the other character at hand. D maps to B, but B maps to B. Next, we iterate over the two strings, one character at a time. Correspond, which we use to map characters in string T to characters in string S to characters in string T. Another dictionary having T, which will be used to map characters in string T to characters in string S. C1 does not have a mapping. It should be P maps to T and T maps to P. I think I see why I struggled with this problem. Now I understand what they mean by mapping. When I read the problem description, I just didn't understand what they meant. All occurrences of a character must be replaced with another character while preserving the order of characters. No two characters may map to this. It doesn't really say whether the two characters should map to each other or themselves, but I guess that's part of the thing with problems like these. But we'll just keep going. Let me see if I can find some more easies. Actually, no pause. So we'll do Excel sheet column title. Given an integer column number, return its corresponding column title as it appears in an Excel sheet. For example, A maps to 1, B maps to 2, C maps to 3, C maps to 26, AA maps to 27, AB maps to 28, column number 1, column number A, column number 28 maps to AB, number 701 maps to ZY. I think what this problem is asking, so we're given a column number in Excel and we want to return its corresponding column title. An integer, return its corresponding column title as it appears in an Excel sheet. So if we're given A, we have to return 1, B return 2, C return 3. No, we're doing the opposite actually. If we're given 1, we have to return A. And if we're given 28, we have to return AB. I think what we're getting at here is that right, is that the column titles, column title is code for base 26, and we can see that because base 10 means that we use 10 symbols to represent all numbers basically, and what they have here is that A maps to 1 all the way up to Z maps to 26. So what we're basically saying is we're going to use 26 symbols, and the character or the number that we're being given, right, we want to be able to basically translate the want to translate the base 10 value, right, to base 26 symbol representation. So when we're given 1, we want to translate it to symbol 1, right? And the 1 symbol in base 26 is A, right? When we're given 701, how can we go about this? I'm wondering if we could go about this like with division. So if we had 28, right, we want to return AB. What AB really means, right, is A, or A maps to 1, but 1 times 26 to the 26 to 1th power plus 2 times 26 to the 0th power, which actually gives you 28. So what we could do is just subtract. We could just subtract numbers. Like for example, we have 28, right? We could say 28. Well, we'd have to start from the left-hand side. We could just say, okay, how many times does 26 go 26 to the nth power go into decimal? and then depending on that number of times, we'll place that symbol. We know that 26 to the 1 goes into 28 one time, so we'll put the symbol for 1, which is A. Then we have a remainder of 2. So now I don't know how many times 26 to the 1th power, which is 1, goes in to 28, and that value is 2. Right? So then we want the symbol for 2, which would be B. So I think what we're going to need mapping of decimal to letter. So something like 1 maps to A. And then we're also going to need to know, I guess, how far to start from the most significant bit. So maybe we'll just choose 10. Actually, we can just use 26, I think. So I think we could do it like so, right? We can say while column number does not equal 0, right? Just to start, we'll say while column number does not equal 0, right? And the power that we're going to start at is going to be 26, right? So while column number does not equal 0, the power is going to be equal to 26. We're going to say, okay, well, how many times does 26 to the 26th power go into the column number, right? How many times does it go into the column number? To figure that out, we could do column number equals column number divided by 26 to the power and I think that should give us a ridiculous value. But if we were to do, like, for example, let me try it on my phone. We're going to do 26, or I guess 28 divided by, let me just check, 26. If we do 26 like no easy way to check. Let me check something. (26) to the 26 would give us a ridiculous number, and then if we divided 28, we would get a really, really small number. So we'll say this will be dividend, and if dividend is less than 1, if it's less than 1, right, then it doesn't go into it, right? So less than 1, then it doesn't go into it. Else, right, it's greater than 1, which means we have some amount that's useful, So we could just say column you'd say column number equals column number mod column number is going to go to column number, right, mod 26 to the 26th power, and then we can actually have, right, column, which will start as an empty string, and then we'll say column, right. We're going to want to add these values to column, right. Column number equals to column number mod 26 times power. And then if we floor dividend, I guess one way to do it is just to say dividend does not equal floor. If dividend does not equal 0, then we know it goes into it at least a number of times, and so we want to update column number with the remainder of that division, and then the actual value that we put to the string will actually be dividend. So just to start, we could say column plus equal dividend dot toString, and then we'd say end power plus equal we'll do power plus equal 1, and then I just want to puts column, but we'll return an empty string for now. I just want to see what we get. Oh no, we want to do we actually want to do power minus equal 1. So this is actually perfect because 1 would map to A. So I want to see if the rest of them map to the correct values. So for expected for AB, we expected 1, 2, which is perfect. And then for ZY, it's actually a little bit hard to read. And we will also do column plus equal comma just to know. So you have 1 and 25. So we have Z, right? And then 1. So A for the first 2 test cases we're good, but for this third one, ZY, we're actually incorrect. And I wonder why that is. We have about 2 minutes remaining. A, B, ZY. 1, 2, 1, 2, 5. $25 would map to 25 would map to Y, but 1 would definitely not be Z. Part of me thinks you might be starting too high. works. So we get 1 and 25. Yeah, for this last test case, Z1, the character 1 would map to A, right? And the character 25 would map to Y. So the fact that we're getting Z for that is concerning. I think that's a wrap for today. I think we should be able to figure this out, though. We're pretty close. We just have one more edge case, but I'll stop there for today.